So here's some common sets of numbers that we deal with: the natural numbers, the integers, and the rationals. Just as a quick review, if I took the number 1, that would be a natural number. But if I took the number -1, that doesn't fit in the naturals anymore, but that would be an integer. And if I took the number 1/5, that's not a natural or an integer, but it is a rational number. And so we can see we have these overlapping sets. But here's the question: where does pi fit in? If you remember, pi is about 3.14, but actually it goes on longer than that. In fact, it goes on forever. Okay, so in that case, you can't write it as a fraction. It's not a rational number. So this gives me a new type of number outside of these three sets. And this picture may not be the best picture to use. Let me draw a new one. So this time I'm going to take the naturals here. And again, I want to surround it with the integers. And I want to surround that. This time I'm going to use a box for the rationals. Okay, but then we saw a number like pi that does not fit in the rationals. And so I'm going to draw a new box over here. And these are for the numbers that don't fall into any of those categories. A special kind of group that I'm going to write it with a Q with a bar over it. And this means the irrational numbers. The irrational numbers are numbers that cannot be written as fractions. We can start writing them as decimals, but those decimals continue on forever, out to infinity. And so they're hard numbers to catch. Are there a lot of them? Well, we know a few of them. How about pi? That's a good one. How about the square root of 2? It cannot be written as a decimal. The value of e cannot be written as a decimal either. And how about like the cube root of 5? If you can see, if I keep going in these type directions, I could come up with a lot of different irrational numbers. In fact, there are more irrational numbers than there are integers. Okay, but you don't have to worry too much about that right now. What I want to point out though is if I collect all of these numbers, the rationals and the irrationals, and so if I'm including the rationals, I'm also including the integers and naturals. These together is what we call the real numbers, and we denote it with a double stroke R like that. And so the real numbers are pretty much any number you can think of between negative infinity and positive infinity. And 99% of the mathematics that you'll do in college algebra revolve around the real number system. So it's really important to understand how these things work. Okay, now I'm going to give you one bonus tip. There is something that extends beyond this. So if I extend this rectangle down into a square, there are some numbers that are not real. Okay, and so these guys are called the complex numbers, denoted with a double stroke C, and they look like this. The set A plus BI, where A and B are real. And this I thing is a curious square root of -1, and we'll talk more about that later. The square root of -1 is not a real number, but that doesn't mean it doesn't exist. Okay, but here's a good picture to have to kind of understand how our number system breaks up. And we spend most of our time, again, in this rectangle here, in the real numbers. I hope this makes sense. Please let me know if you have a question. I'll be glad to help. Make sure you understand this terminology well, and thanks for watching.